Welcome. I'm Dr. Ewan Pritchard. I'm Director of Industry and Innovation for the FREEDM Systems Center. One thing I wanted to talk to you about today is the three-plane diagram for our center. The three-plane diagram describes the relationship between the demonstration plane technologies, the enabling plane technologies, and the fundamental plane technologies. Traditional universities are very good at this fundamental science work, but one of the challenges that happens is it's very difficult to take that fundamental science and make it applied in the marketplace. So one of the things that we do is we push this overall vision. We work from building the overall 1 megawatt green energy hub testbed and transfer the problems with implementing that testbed down into the individual groups and finally to the fundamental science level. What that allows us to do is get a better sense of the marketplace, the needs of the marketplace, and incorporating research into traditional industry models. Underneath that 1 megawatt green energy hub, we feel like there's three major components needed: intelligent fault management, intelligent energy management, and plug-in hybrid electric vehicles or plug-in electric vehicles. What's needed to make those individual components happen are a system of technologies that are required to overcome certain hurdles in the marketplace. So what we're working on here is we build out the first generation of 1 megawatt green energy hub testbed, and then underneath that we incorporate intelligent fault management, intelligent energy management, and plug-in hybrid vehicles. The first generation of technology will then help us understand what some of the hurdles are to implementing those technologies, or some of the things that we could do to improve upon those technologies. And then those concerns are then communicated down to the other subgroups that feed into them. Let's take a look at just one of these test beds. Intelligent fault management is led by Dr. Misha Stewart at Florida State University. It incorporates the enabling technology of distributed grid intelligence and the fault isolation device. Those technologies, or the people leading those groups, hear from Dr. Stewart as to the successes or failures or challenges facing the first generation technology, and he helps dictate what happens in the following generations of both distributed grid intelligence as well as fault isolation devices as it relates to the intelligent fault management. And then each of these groups then take their first generation of technology and explain to the system theory modeling and control people what's going on with distributed grid intelligence. They also explain to the post-silicon device group what is needed for a better fault isolation device. So the same thing goes on with intelligent energy management with Dr. Marissa Crow at Missouri Science and Technology. She works closely with the group developing the solid-state transformer, the group developing distributed energy storage devices, the group developing distributed grid intelligence, and the group developing reliable and secure communication. By working with each of the leaders of those groups, she can dictate then what goes into the generation 2, and the generation 3, and the generation 4. Now each of these groups with their generation 1, what they do, again, is dictate to the group below them what is needed in the next generation. So these are the groups working in very specialized labs, working on very specialized technologies. Things such as post-silicon devices. You've got people working on gallium nitride or silicon carbide devices, building the next generation of IGBTs. Here in advanced storage, you've got groups working on what are some of the failure mechanisms in today's batteries, and what are some of the ways we can build new anodes and cathodes to improve those batteries. And then in system theory modeling and control, you've got people working on what are some of the ways that you can add new distributed control to a large-scale system without having to collapse. And so this should help you get a broader perspective of where your research falls within the three-plane diagram, as well as a broader perspective on how your technology can help the overall system. Thank you.